In this lesson, I'm going to cover how to create and set up a site-to-site IPSec VPN tunnel using Cisco's Adaptive Security Appliance. Before getting into the details and configuration of setting up a VPN tunnel, I want to give you a brief summary of why people use VPN technology and some of its use cases. So, what is the purpose of a VPN? The purpose of a VPN is to provide a secure channel of communication that provides data privacy when using unsecured communication links, such as the internet, for example. VPN tunnels are used for business-to-business communications, off-site locations, branch offices, and remote users. Building a site-to-site IPSec VPN tunnel contains two key components called Phase 1 and Phase 2. Phase 1 uses the Internet Security Association and Key Management Protocol, or better known as IPSec, which is basically the control plane or management portion of the tunnel. Its job is to ensure that both peers are authenticated and have a mutual agreement to actually build the tunnel. The Phase 2 portion of the tunnel is what is considered the data plane. It's the portion of the tunnel in which the data traffic will pass through. Now that I've briefly explained what a site-to-site IPSec VPN tunnel is, let's look at the topology we'll be working with in this lesson. In this topology, we have a site A and a site B. Both sites have a connection to the internet as well as their own private networks. What we want to do is create a secure channel of communication between workstation A and workstation B by using a site-to-site IPSec VPN tunnel. The first step to building the tunnel is to create the Phase 1 policy, also known as the IKE or IKE policy. Phase 1 uses UDP port 500 as a transport to communicate with the peer in order to begin the startup process of the tunnel. You need to enter the global configuration mode and do a crypto IKE v2 policy command, like so. The number 10 in this configuration defines the sequence number of the policy, meaning that you can have multiple sequence numbers to define different policy settings. You and your peer must match on at least one of the configured policies in order to begin building the tunnel. Now that we've created the policy sequence, next we need to define the encryption algorithm that will be used. For this lesson, I'm going to select AES 256, but you may choose any encryption algorithm that suits your particular needs. This encryption portion of the policy will encrypt the data traffic from being sent in clear text as it goes through the tunnel. Next, we need to define what Diffie-Hellman group you will be using for the policy. The Diffie-Hellman group determines the strength of the key used in the key exchange process with the remote peer. For this lesson, I'm going to choose Group 5. Lastly, we need to define what integrity algorithm will be used. In this example, I'm going to configure SHA 256. The next step, which is a step that many tend to forget to implement, is the enabling of IKE on the interface facing the peer. In this example, it is the outside interface. If IKE is not enabled on the interface facing the peer, the tunnel will not come up. The reason for this is because enabling IKE on the interface turns on the UDP port 500 communication between the peers. The next step we need to configure is the IPSec proposal, an interesting traffic ACL. The IPSec proposal, also known as the transform set, is a component of the Phase 2 process of the tunnel. It defines how the data traffic going through the tunnel will be encrypted, as well as what data integrity algorithm will be used. In this example, I'm going to create an IPSec proposal named my-proposal. We then need to specify what encryption and integrity algorithm we'll be using. For this lesson, we'll be using AES 256 for the encryption and SHA-1 for the integrity. Now that we have our IPSec proposal configured, we need to configure our interesting traffic ACL, or access control list, which simply defines what source and destination traffic should travel through the tunnel. When some people think of ACLs, they typically think of them as performing some sort of traffic filtering. But in this scenario, the ACL is used as a means of identifying traffic. So now I'm going to create an extended ACL named Interesting Traffic, identifying the source network as 192.168.1.0/24 and the destination network as 172.16.1.0/24. As you can see, here we identify the source network, and here we identify the destination network. Next, we need to create a tunnel group. The tunnel group defines the tunnel type, the peer's IP address, and how the peer will be authenticated. Tunnel peers can be authenticated using a pre-shared key, aka password, or they may be authenticated using certificates. In this lesson, we're going to be using a pre-shared key. Now, before I show you the configuration, I want you to be aware that the tunnel group name by default must be the IP address of the peer. So now we're going to create the tunnel group with a name of 10.10.10.2, which is our peer's IP address. Then we need to set the type of tunnel we're going to be using. Since we're building a site-to-site tunnel, we'll be setting the tunnel type to IPSec L2L, which stands for IPSec LAN to LAN. The last configuration step in the tunnel building process is to create and apply what is called a cryptomap. The cryptomap is where we tie together the interesting traffic ACL, the IPSec proposal, and the peer's IP address. Before showing you the configuration of the cryptomap, I want to mention a key thing to remember when creating and applying your cryptomap, which is that you can only have one cryptomap per interface. However, you may configure multiple sequence numbers to a cryptomap just like you can with the IPE policy. Now for the configuration, I'm going to create a cryptomap named My Cryptomap with a sequence of 10. Now we need to tie in the interesting traffic ACL by doing a match address and the name of the interesting traffic ACL that was created earlier. Then we need to tie in the IPSec proposal that was created earlier by doing a set IKEv2 IPSec-proposal and the name. The last portion of the cryptomap that we need to set is the peer's IP address by doing a set peer and the peer's IP address of 10.10.10.2. Finally, we need to apply the cryptomap to the interface facing the peer, which is the outside interface that connects to the internet. Now that we've completed all of the required configurations, let's double check our configurations by issuing a few show commands. First, I'm going to issue a show run crypto command, which will show us the IPE policy, the IPSec proposal, and the cryptomap. Next, I'm going to issue the show run tunnel group command. This will show us the tunnel group portion of the configuration. Before configuring the ASA at Site B, let's go to the workstation that resides in the 192.168.1.0/24 network in Site A. I'm going to issue the IPconfig command so that we can see the IP address of workstation A, as well as the gateway IP address, which in this scenario is the inside interface of Site A's ASA 192.168.1.1. Now let's start an unlimited ping to the workstation that resides in Site B. The pings, of course, will not be successful until we configure the ASA at Site B. The reason I'm doing this is because I want you to see the result of this ping session once we finish configuring Site B's ASA. Let's now move on to configure the ASA at Site B. We're going to configure the same policy settings and names as we did on Site A's ASA, but keep in mind that all peer IP settings will now point to Site A's IP address, and our interesting traffic ACL source and destination will be reversed. First, we need to configure the IPE policy and enable it on our outside interface like so. Next, we need to create our IPSec proposal and interesting traffic ACL. Next, we need to create the tunnel group, and again, this time the IP address will be Site A's ASA. Finally, we create the cryptomap and apply it to the outside interface, which again is the interface facing the peer. Now that we've finished configuring Site B ASA, if everything was configured properly, we should see the tunnel come up by doing some simple show commands such as show crypto ISACMP SA and show crypto IPSec SA. The first show command will show you if the phase 1 or management part of the tunnel is up. The second show command will show you if phase 2 is working properly, meaning your data traffic is being protected, encrypted as traffic goes out the tunnel, outbound, and decrypted as traffic comes from the tunnel, inbound. Now, a key thing to note is that you must generate some traffic to bring the tunnel up. If you don't generate at least one packet of traffic, the tunnel process won't start. Since we have the unlimited ping session going on the workstation at Site A, the tunnel should already be built by now. Let's check with our first show command, show crypto ISACMP SA. After issuing the command, we can see that the phase 1 portion of the tunnel is up and active. We can also see our remote peer's IP address and the UDP port 500 that we're using for communication, and our role as the responder. Site B ASA is the responder because the tunnel building wasn't initiated by Site B, but instead Site A, hence the pings coming from the workstation at Site A. Next, we're going to issue a show crypto IPSec SA command. Here, the key thing that you want to see is if the packets are being encrypted and decrypted like so. This confirms that the phase 2 portion of the tunnel is functioning properly. Also displayed in this output is the source and destination networks that are going through the tunnel, which was specified by the interesting traffic ACL. Let's finally check the ping results on the workstation that resides in Site A. As you can see, the pings are successful. If for some reason the tunnel doesn't come up, here are a few things you can check. The first thing you can check is to see if you have basic connectivity to the peer. You can also check to see if you have a route in the routing table to your destination networks, or at least a default route. Also, verify that you have your IPE policy enabled on the proper interface, as well as verifying that you applied the cryptomap to the proper interface. This concludes this lesson on how to configure a site-to-site IPsec VPN tunnel using Cisco's Adaptive Security Appliance. Thank you for watching.